Hello everyone. In our last class we have discussed about the coordinate systems. Now we will see the new topic, that is the Coulombs law. Coulombs law is basically applicable for the point charges. Point charge is one of the charge configurations and it is very small compared to the distances involved in the calculations. So, point charge is smaller one compared to the distances. You will be understood about the distance after seeing this particular Coulombs law. So, point charge is very small compared to the distances involved in the calculations. Compared to the distances involved in the calculations. With what distance you are going to deal with the comparison with the particular distance, these dimensions of the charge is very small. Then we can able to consider that particular charge as the point charge, and Coulombs law is applicable for the point charges. That is the first point regarding the Coulombs law. Now, using this particular Coulombs law, we can able to get force on one point charge due to another charge or due to more than one charge. So, we can able to get the force on one particular charge. That can be done by using this particular Coulombs law. So, if you assume here x axis is coming towards you, so this can be drawn in different manner also, that is like this. Here y axis, z axis, that means this particular screen is representing the yz plane and x axis is coming towards you. The positive x axis is coming out of the plane, out of the screen, that can be indicated like this dot circle. Then in this particular space we have two point charges, one is q1 and second one is q2. On q2, how much amount of force is available due to the point charge q1, that is what we are going to find now using this particular Coulombs law. And these two point charges are joined by using this particular line, and that vector which is joining these two is represented with r bar or r12 bar. So, now the force experienced by charge q2 by charge q1 is represented with f12 bar, and the magnitude of that particular force is proportional to the individual charges. That means, it is proportional to charge q1 and it is also proportional to charge q2, and it is inversely proportional to the square of the distance between those two, that is magnitude of r12 square. So, by using this particular information, we can able to write the magnitude of the force which is experienced by the point charge q2 due to the point charge q1, that is given by magnitude of f12 is proportional to q1 q2 by magnitude of r12 square. If we remove this proportional, we will get a proportionality constant, that is given by f12 is equal to 1 by 4 pi epsilon q1 q2 by magnitude of r12 square. This is the magnitude, but force is a vector. So, it is also having the direction, not only the magnitude, it is having the direction also. So, in which direction this particular force is available means the line which is joining the two point charges. So, along that particular line this particular force is available. So, the force is along the line which is joining the two point charges, like that we have to consider the line vector which is joining the two point charges is already given here, that is r bar or r12 bar. Why r12 or f12 means the second suffix is indicating on which charge the force is available. This first suffix is indicating due to the charge q1 and this is on charge q2, like that we can able to consider. f12 is also like that only, and the r12 bar is joining the charges q1 and q2 and that is towards q2 only. So, the force direction is represented with this particular arrow, that is towards q2 from the q1, like that we have to give. So, we have to take the unit vector regarding that particular line vector or the distance vector which is joining the q1 and q2. So, finally, this F12 bar is given by 1 by 4 pi epsilon q1 q2 by magnitude of r12 square into r12 cap. So, along the r12 cap the force direction is available and the magnitude of F12 is given by 1 by 4 pi epsilon q1 q2 by magnitude of r12 square. And for example, there is a vector called a bar that is equal to 2 ax cap plus 3 ay cap plus 4 az cap. This is the vector we have taken. How can you tell is this vector unit vector or not? Means we have to calculate the magnitude of the vector a bar. If it is equal to 1, we can tell that is a unit vector. If it is not equal to 1, we can say that is not a unit vector. So, we will find that one. So, magnitude of a bar is equal to square root of 2 square, that is 4, plus 3 square, that is 9, plus 4 square, that is 16. So, you are getting here root 29. So, it is not equal to 1. So, the vector a bar is not a unit vector. How to make this vector as a unit vector? Means simply we have to divide the vector a bar with its magnitude. Then what will happen? You see, a bar by magnitude of a bar, that is equal to one vector we will get, that is 1 by root 29 into 2 ax cap plus 3 ay cap plus 4 az cap. Now, it is a unit vector because 1 by root 29 is a number, that is a scalar, and the magnitude of this 2 ax plus 3 ay plus 4 az is already root 29. So, root 29 by root 29 means 1. So, the vector a bar by magnitude of a is having the magnitude is now 1. That means a bar by magnitude of a is the unit vector. A bar is not a unit vector, but a bar by magnitude of a is a unit vector. Already in this force equation we have written here unit vector. So, that r12 cap can also be written as r12 bar by magnitude of r12 using this particular concept. So, the force equation can be remodified as like this: F12 bar is equal to 1 by 4 pi epsilon q1 q2 by magnitude of r12 square. This is from the magnitude. Next, this r12 cap we can write as normal vector r12 bar by magnitude of r12. Now, in the denominator if you observe, r12 cube is available. So, we can rewrite this one as F12 bar is equal to 1 by 4 pi epsilon q1 q2 r12 bar by magnitude of r12 cube. So, like this also we can able to write the force equation. If you want to write using the unit vector, in the denominator square of the distance is there. If you want to write using the normal vector r12 bar, in the denominator you will be having cube of the distance vector, magnitude of the distance vector will be available. That is the thing you have to remember. So, this is actual Coulombs law. You need to tell Coulombs law is nothing but the force is inversely proportional to the square of the distance only, but after remodifying that one you are getting this equation. Okay. So, now we will write in different manner using the position vectors. The point q1, the point charge q1 is available in the free space at coordinates x1 comma y1 comma z1. Here we are using the Cartesian coordinate system. So, that particular point or the position of the point charge q1 is given by the location x1 y1 z1. So, that the position vector is available for that particular position, that is this one, that is I am taking as this is position p1. So, op1 is the position vector. So, here op1 bar is given by x1 ax cap plus y1 ay cap plus z1 az cap. Similarly, the point charge q2 is available in position p2 where the coordinates are given by x2 y2 z2. So, the position vector of that particular point charge q2 is given by op2, that is equal to x2 ax cap plus y2 ay cap plus z2 az cap. Now, this OP1 bar I am taking as R1 bar, OP2 bar I am taking as R2 bar. Now, if you observe here 3 vectors are involved. One is R1 bar, second one is R2 bar, and third one is the distance vector which is joining the 2 point charges Q1 and Q2, that is R12 bar or R bar, whatever it may be. But if you observe one thing, that is the head of the vector R1 bar is connected to the tail of the vector R12 bar. So, for these two we can able to apply vector addition rule, so that we will get R1 bar plus R12 bar is equal to R2 bar. But what we need in our force equation, R12 bar is required. So, R12 bar is equal to R2 bar minus R1 bar. What is this one? R2 bar is the position vector of the point charge Q2 where we are finding the force, and R1 is the position vector of the point charge Q1, due to Q1 only we are getting the force, that is the cause for the force. Okay. So, how to remember this one? We can able to tell that R2 bar is the position vector of the destination charge or the observation charge or the test charge. Okay. You can take it is a test charge or destination charge, or it is related to the destination position, observation position. And what about this R1 means? It is the source, it is the actual reason for the force. Okay. So, it is a source charge or source position, like that we can able to take. So, everywhere, not only in this particular Coulombs law, after that based on this Coulombs law we are going to get the electric fields due to the point charges. So, in those calculations also we need to calculate this distance vector. Calculation of distance vector is very important, and in that case what we need to remember means observation point position vector minus source point position vector. These are the things we have to remember. Okay. So, what is now magnitude of R12 bar? That is simply the magnitude of R2 bar minus R1 bar. So, what is our previous force equation we have given? F12 bar is equal to 1 by 4 pi epsilon into Q1 Q2 by magnitude of R12 cube into R12 bar. So, in place of R12 bar, using the position vectors, now we can able to rewrite this particular force equation like 1 by 4 pi epsilon into Q1 Q2 by R2 bar minus R1 bar, its magnitude we have to take whole power 3 into R2 bar minus R1 bar. So, like this also we can able to write the force equation, Coulombs law force equation, like this also we can able to write. Okay. Now, one thing we do not know in this particular equation, that is this epsilon, this is called epsilon. Epsilon is actually the permittivity. Okay. Here I will write epsilon is actually the permittivity of the medium where these 2 point charges are available. Permittivity, or this can also be called as the capacitivity. So, what is this one? It is the property of the medium, and it is indicating the ability of the medium to store the electric fields in that particular medium. That means, if you take more value for the permittivity, that type of medium if you select the medium which is having the higher value for the permittivity, then the medium can able to store the electric fields in that particular medium heavily. If you take the medium which is having the permittivity is low value, then the ability of the medium to store the electric fields is less. So, this property will be helpful in the antennas case. In case of the antennas, the electric fields should not be available in the medium. The electric fields should be radiated. Okay, it should come outside, the electric fields should come outside. That means, we should select the medium which is having the permittivity is less in case of the antennas. Okay. So, the permittivity of the free space is given by epsilon naught, and the value of that one is given by 8.854 into 10 power minus 12 farads per meter, or that can also be given by 1 by 36 pi into 10 power 9 farads per meter. Farads are the units for the capacitance, that is why it is related to capacitivity also. and then in the calculations we need always 1 by 4 pi epsilon naught. So, that if you calculate the value of that one, you will get 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. So, directly when you are dealing with the free space, you can able to take 1 by 4 pi epsilon naught is nothing but 9 into 10 power 9. Okay. So, this thing you can able to use in the problems.